For chapter 4.3, there are two kind of key parts. And how can we check if my function f is increasing or decreasing? So we check the first derivative fx. So if it is greater than or equal to 0, then my function is increasing. If it's less than 0, then it's decreasing. And how to check the function is concave up or concave down? We check the second derivative function. If second derivative is greater than or equal to 0, then it's concave up. And if second derivative is less than or equal to 0, then it's concave down. And the third important part is how to find the implication point. So that's a point where changes the concave, like from concave down to concave up, or from concave up to concave down. And for question 3, so the question gives you a graph. And question A is if f.5 is it positive or negative? So when x equal to 1/2 positive 5, it's y in this point. So the curve is above the x-axis, so it should be positive. And second is check the first derivative fx at x equal to 0.5. Is it negative or positive? So we know if the first derivative is greater than 0, then it's an increasing part of the function. And if the first derivative is less than 0, then the graph is decreasing. So from the graph, we can see at x equal to 0.5, and the curve is decreasing. Because it's decreasing, so its first derivative should be less than 0. So that's why it should be negative. How about second derivative at x equal to 0.5? And we know second derivative is to check the graph is concave up or concave down. For x equal to 0.5, and this part is concave down. So which means the second derivative should be less than or equal to 0. So which means it's negative. And for question 5, the given function is fx equal to 9x plus 8 times x to the power -1. So x to the -1 power is just 8 over x, just 1 over x. And here we can see, because x is in the denominator part, so anything in the denominator part cannot be 0. So here the domain is x does not equal to 0. And from the descriptive of the question, it says b is a point, like x cannot be. So we can know b should be equal to 0. And the other 2 points, A and C, they are the critical points. So from the first section, we know critical point. We just need to find the first derivative of the function and set it to be 0. So we just need to solve the first derivative of fx and set it to be 0. And we can find x is a positive plus and minus square root 8 over 9. So this is a typo. So x has 2 values. One is positive 8 over 9 and one is negative 8 over 9. So we can find the 4 important intervals. So I think that's for question A, because it says b is a value like x cannot be from the domain. So x cannot be 0. So b is 0, and A is just the left side of the endpoint, so which is negative square root 8 over 9, and c is just a positive square root 8 over 9. And second part is to find if x is increasing or decreasing in the given intervals. And we know to check if fx is increasing or decreasing, we should use the first derivative rule. So you just check the first derivative of fx. If it's greater than 0, then it's increasing. So for example, for first interval negative infinity to a, which is negative square root 8 over 9. So square root 8 over 9 negative is around negative 0.94. So the first derivative, we can find one value. You can use any random value, like a negative 1, because negative 1 is inside this domain. We can check f negative 1 prime first derivative, and which is greater than 0, so it's increasing. And for the other intervals, you can just use any value to check if the first derivative inside that interval is greater than 0 or smaller than 0. Then the third part is to check the fx is concave up or concave down. So it's the same. You need to check the second derivative of fx during that interval if second derivative is greater than 0 or less than 0. If it's greater than 0, then concave up. If it's less than 0, then it's concave down. And for question 7, I didn't plot the graph, but here the thing you need to pay attention to is the graph given in the question. That's the first derivative of f. So f prime, that's not the graph of x. So the first question is on what interval f is increasing, because the given graph is f prime. So at what interval f is increasing? You just to check when x equal to which values f prime is 0. So that the graph is above the x-axis. And second is on what intervals f is decreasing. So you can just see on the graph which values of x can make the graph less than 0, that's below the x-axis.